Hey guys, here are notes for 5-4. Okay, so pay attention. The good thing about a video is you can pause it, you can rewind it if you need to. Okay. So today we're going to talk about solving systems of equations by graphing. So a system of equations is simply more than one equation. Okay, so first we're going to look at a couple of situations on what kinds of solutions you're going to see. Okay, so it says use the graphs below to determine whether each system has one solution, no solution, or infinite many solutions. Okay, notice that the first one has two lines that are parallel. Since they do not intersect, they have no solution. Okay. The second one is two lines that do intersect, and they intersect at one place. And that means they have one solution, and the solution is the point that they share. In this case, that point is 5, 1. Okay, third situation, you only see one line, but there really are two lines there. So basically it's the same line. The lines are on top of each other. Okay, so what that means is that they have infinitely many solutions, or all real numbers. Remember, the symbol for all real numbers is that. Okay, and then the last situation is two lines, equations of lines. So notice that they have the same slope. Okay, -3/3 is -1, and then that has -1. But they have different y-intercepts so that they're parallel lines. So that means they don't intersect, so therefore they have no solution. Okay. All right, the next type of questions is we're going to look at two equations, and we're going to have to state whether the ordered pair is a solution to a system. So we're given a possible solution, and we need to state, is that a solution? Okay, so basically your answer is yes, it is a solution, or no, it is not a solution. And we need to determine how to get that answer. Okay, so the first thing, notice that they are in standard form, so we need to change them to y equals mx plus b form. So this first one, subtract x. Okay, and then everything changes, so either divide by -1, multiply by -1, doesn't really matter. So you get y equals x minus 6. So there's my first one, y equals x minus 6. My next equation, subtract 2x from both sides, and that's the only thing we need to do. Y equals -2x. Okay, so there's several ways you can do this. So you could plug in that point, x and y, into both equations to see if it is a true statement, to see if that point is on both of those. But I do want us to get in a habit of using the calculator. So if you don't have your calculator out, go ahead and hit pause on the video and get your calculator out. Alright, what we want to do is we want to graph both of those lines in y equals. So I'm going to go to y equals. I'm going to turn my plot off, and if there's anything else in any of these equations, I'm going to just delete them, clear them out. Okay, so my first equation is y equals x minus 6. So in y1, I'm going to put y equals x minus 6. And my second equation is y equals -2x. Okay, so we're not specifically trying to find the solution, we're just trying to determine if the point -2, -4 is on both these lines. So I'm going to hit second graph, and I'm just going to look at the table. okay, and I'm looking for the point -2, -4. So here's when x is -2, the first graph is -8. So it's not on the first line, and it's not on the second line. So what that means is that point is not a solution, okay? So your answer would be no, it is not a solution. Okay. Now what I would like you to do is I'd like you to pause the video and try the second one. So hit pause, try the second one, and then hit play, and you can check your answers. All right, let's see how you did. So first, you've got to change the form. So you should have subtracted 2x from both sides. You get -y is -2x plus 4. Divide -1 by everything. Y is 2x minus 4 is the first equation. And then same thing for the second one. Subtract 3x. That's all we needed to do. So you get y equals -3x plus 1 is the second equation. Then we need to put that into our calculators. We go back to y equals, and again, start with fresh. Y equals, so my first one is 2x minus 4. And then the second one is -3x plus 1. And again, I'm not looking at the graph, I'm looking at my table. So I'm going to go to my table, and we're trying to determine if the point 1, -2 is a solution. So when x is 1, the first graph is -2, and the second graph is -2. What that means is that point is on both those lines, so they actually do intersect at that point. So your answer is yes, it is a solution. Okay, it is a solution to those equations. Okay, we're looking for the point of intersection, or the point that makes both equations true. Okay, all right, let's move to the second page. Okay, so the second page says graph each system of equations, then determine whether the system has one solution, no solution, or infinitely many solutions. If the system has one solution, name it. And then we do need to make sure to sketch our graph. Okay, so the first thing we need to do is graph each system of equations. Okay, so you can do this by hand. Okay, I'm going to show you both. So if I was to graph it by hand, this first one has a y-intercept of 6, so I'm going to graph that y-intercept, and it has a slope of 2, so I would move up 2, right 1, okay, and it's really hard digitally, but if you are doing this on paper, you can use a straight edge, and you can get an exact straight line. Okay, so I'm going to do my best digitally to make a straight line. It would look like that. Okay, then my next equation is -x minus 3, so I'm going to graph the y-intercept, which is -3, and I'm going to move up 1, left 1, up 1, left 1, up 1, left 1. Okay, and I'm going to connect those points. And as you can see, since I was not using a straight edge, I didn't get a very friendly point of intersection. It is right in the middle. Okay. So I'm going to show you a different way to do this. Okay, graphing by hand always works as long as you use a straight edge, use a ruler. Okay, now another way to do it is using your calculator. Okay, so we're going to go to the calculator. I'm going to graph both these lines, one in y1, the other one in y2. So the first one's 2x plus 6. And then the second one is negative x minus 3. Greater illustration here on the difference in a negative sign and a minus sign. Okay. And then I'm going to look at my graph, and I'm going to start with my standard window, zoom 6. Here comes that first line, and here comes the second line. So you can see it looks extremely similar to how I graphed it by hand, except for there's a very distinct point. So there is one solution. Okay, there is one solution. We need to know how to find that solution. Okay, so we need to find that intersection. And here are the button strokes. You're probably going to want to write these down. Second, trace, 5, enter, enter, enter. And it tells you the intersection is -3, 0. Okay, so this one has one solution. And that solution is -3, 0. Okay, remember your button strokes were second, trace, 5, enter, enter, enter. Okay, now we're going to do number 4 together. All right, we'll do number 4 together. So whether you find the answer on your calculator or not, you always need to sketch a graph. Okay. All right, number 4. So notice that they're in standard form, so we need to change the form first. All right, so the first one is 2x minus y equals 1. Subtract 2x from both sides, you get -y equals -2x plus 1. Divide everything by -1, so y is 2x minus 1 is the first equation. Okay, so then my second one, we've got 4x minus 2y is 2, so I'm going to subtract 4x from both sides. Get -2y equals -4x plus 2. Divide everything by -2. Y is 2x minus 1. Wait a minute, what do we see? Well, you can see that both of the equations are exactly the same. Y equals 2x minus 1. So if I was to graph it, graph the y-intercept -1 up to right 1, both of them look exactly the same. So it's the same line. Okay, so imagine a line graphed and then another line graphed right on top of it. Where are they intersecting? Everywhere. So the solution is all real numbers. Okay, all real numbers. Now, here's what I want you to do. I want you to pause the video and try the last one. And when you get done, hit play and check your answers. All right, let's see how you did. So they're both in standard form. We need 2 changes. So this first one, 4x minus y equals 3. Subtract 4x from both sides. -y is -4x plus 3. Divide everything by -1. Y is 4x minus 3. And my next equation, add 4x to both sides. Get y equals 4x plus 9. So you see immediately that they do have the same slope. Okay, so remember from previous chapters, the same slope means that they are parallel lines. All right, so I do want to go ahead and graph. So if I graph this one, slope of y-intercept of -3, slope of 4. Next one has a y-intercept of 9, slope of 4. So you do get parallel lines. They do not intersect. Since they do not intersect, what that means is there is no solution. Now, I do want us to put them in the calculator to see what that looks like. Okay, so again, graph one in y1, the other one in y2, and this is just good practice. So we have 4x minus 3 and then 4x plus 9. I want to look at the graph. So they do look parallel. So let's see what happens if I was to find the intersection. So I'm going to hit second, trace, 5, enter, enter, enter. It says no sign change. Okay. It says calculations are not detecting a sign change to give an estimated result for the allowed number of iterations. So this will happen if they are parallel, and it will also happen if they intersect but you don't see the intersection. So if you know they have different slopes and they're going to intersect, you need to change your window and show the intersection in your window before the calculator can calculate it. And we'll look at some more of those later. So those are your notes. Do your assignment. Check your answers. Okay. And I will see you guys next time.